Now we've dealt with the remainder theorem. We're going to look at a specific situation of the remainder theorem, which we classify and call the factor theorem. So say I've got a polynomial that looks like this. 2x cubed minus 5x squared minus 4x plus 3. And I want to divide that by x plus 1. Well, if I go and take my division algorithm and do it long division wise, it's going to look something like this. I get x plus 1. This is going to be 2x squared, 2x cubed plus 2x squared. Take that away, it's going to be minus 7x squared minus 4x. So that's going to be minus 7x. Minus 7x squared minus 7x. And I'm going to take that away, so I'm going to be left with 3x plus 3. And I'm going to put a plus 3 over there. There's going to be 3x plus 3. And, oh wait, hang on, there's no remainder. What does that mean? Well, it means that this term over here is in fact a factor of the polynomial. It divides exactly into the other polynomial. So if I go and say 15 divided by 5, I get the answer 3. There's no remainder left over. 3 is a factor of 15 and 5 is a factor of 15. So in this situation over here, x plus 1 is a factor of this polynomial. Now, that's going to become a really important feature because this gives us an entry point to try and factorize cubics. These expressions that we've got up at the top over here. We have a general quadratic formula that works for quadratics, but we don't have at this stage any specific way of being able to factorize a cubic, and the factor theorem is going to help us in this regard. And so we have a formalized version of this, and we can say, right, here is our factor theorem. If a polynomial p of x is divided by any linear expression of the form ax minus b, then the remainder is 0, then p of b over a equals 0, and ax minus b is a factor of p of x. So that's a really useful tool to have. If we go back to this example that we've got at the top over here, what we've been able to say so far is this. We can say 2x cubed minus 5x squared minus 4x plus 3. That is equal to x plus 1 multiplied by 2x squared minus 7x plus 3. So we've factorized the expression over here. In fact, I can take this further. In fact, I can say, right, this second expression is a quadratic which I can factorize, and I'm going to factorize it as 2x and x, and I guess it's going to be 3 and 1. And if I make them both negative, I'll get minus 7x. And so now I've gone and factorized this expression, this cubic expression, fully. And that then allows us to go and take this situation and solve it. So in other words, I could ask you to solve 2x cubed minus 5x squared minus 4x plus 3 equals 0. So you now have a way of being able to see if you can factorize and therefore solve this cubic, because we've just seen this cubic can be written as the product of these three factors, and so therefore I can say x is going to equal -1 or a half or 3. Any one of those 3 are a possible solution to that cubic graph, that cubic function. Hope this helps. Goodbye.